All right, we are back now. We are on our last section of this prerequisite chapter, and I've broken it down to chapter 1 and chapter 2. So we're on the last section for chapter 2, last review section. So after this chapter and test, we'll be moving on into the actual pre-calculus portion, which there'll be a lot of new things going on there. So it's great that we're at this point now because we're about to finish up our predictable math patterns, biblical integration that we've been talking about the last 6 sections or so. And just know for the last video, which will be the test review, we'll do one last thing to tie it all up. But we've been talking about how God and math coincide, how God's character is shown through math, which is his creation. And we read this biblical statement at the very beginning of it, so I want to read it to you again. God compares his promises, dictates, and laws for humans against the standards of those regulations set for creation. In fact, God states that the mysteries of the universe reflect the mysteries of his nature. A stable universe is necessary for the world to operate properly. Math does not work unless God's order is established in his creation. Order makes logic possible. Logic sets patterns. Patterns allow people to build. Building assumes predictability. Prediction is only possible if there is stability, something one can count on. And so we talked about what were the characteristics of God that are also shown in math that we can see play out when we work math problems that we can glorify God with. Well, we know God is consistent. And we see that through his word and through math. We know that God is faithful. He's dependable. He's reliable. We know he's orderly. We know he's immutable. We know his truth. And we have all these verses that we talked about beforehand showed it. Now we have 2 outcomes or attitudes that's today what I want us to do. So we're going to read 3 and 4 here. These are what you should be thinking about as you work through your math and as we've gone over through all these different characteristics. Number 3. I can find joy in the discovery of God's rich and abundant patterns in his creation. And I'm going to show you something next lesson. It's called the golden ratio and the golden rectangle. And it's pretty cool. And I want to show you how that plays out in God's creation. And then lastly, number 4, design, which was introduced by God at creation, is pleasing to my eyes. And there's a verse here, Genesis 2:9. Let's read that. And out of the ground the Lord God made to spring up every tree that is pleasant to the sight and good for food. The tree of life was in the midst of the garden, and the tree of knowledge of good and evil. And so what we're seeing here is that God's predictability and his design and his proportionality, his characteristics are pleasing to us. There's a study done why some people are attractive, and they showed that it was the faces that were more proportional were more attractive to our eyes. I think that's kind of interesting to see in a world that's so, if you were an evolutionist, you believe in entropy, which is this whole idea that things go to chaos. Things, think about it as like a pile of clothes. When you put it in the laundry, they don't come out folded. They come out messed up. And that's what entropy is. That's what evolution is. But when we look at patterns, it's pleasing to us, which goes against everything that's out there. But because God is our creator and that's how he created things, it's pretty cool. So let's go ahead and get started with today's lesson. I want you to see that as we're going through today's lesson and just try to glorify God as we work through this. So this whole section, which is P.6 or 2.3, whatever we're going to call it, is about complex numbers. And you might be asking yourself, well, what's a complex number? Complex number is just another way of saying imaginary number. You might have, you should have. You have probably heard of, I didn't want to do that, imaginary numbers in Algebra 2. You may have talked about it a little bit in Algebra 1. But that's the main thing for Algebra 2. So complex numbers are this whole idea of not real numbers. They are imaginary. And so what we're going to learn about today is what complex numbers are how we can do operations with complex numbers, how we can use complex conjugates for division, and how to do complex solutions of quadratic equations. And why are we learning this? Well, we're going to do a whole chapter on polynomials. And the zeros of polynomials are sometimes complex numbers. So we have to understand how to deal with those zeros before we move on to that chapter. So we have to know how to do complex numbers. That's why we're doing this. So what is the term a complex number? A complex number is any number that can be written in the form that you see there, which is a plus b times I. So it's some number plus some number times I. So a and b are real numbers. The real number a is the real part. The real number b is the imaginary part because you see the I there. Okay? If a plus bi and c plus di are two complex numbers, then all you have to do is add them. So this is a fancy way of just saying you can combine like terms. Let me see if there's an example here. This is multiplication. But basically, if this was 5 plus 3i and 5 plus 2i, you just add the 5's together, right? A and C. So it'd be 10, and then you add these two together. So it'd be 10 plus 5i, right? And you can do the same with the subtraction. What about multiplying? Well, when we multiply, we have to FOIL, right? So it's going to be 3 times 4, which is 12. 3 times that negative I, which is negative 3i. 2i times 4, 8i. 2i times negative I squared. This is the part that confuses people, so we'll come back to this in a minute, okay? So we're going to deal with this guy right here, 12. We can't combine that with anything, so it's going to stay 12. We have a negative 3i and an 8i, so when you add those together, that becomes 5i. Then we have this guy to deal with. Know this right now. I squared is negative 1. In fact, and I'm going to write this out here. I don't know why it's not on the notes, but that's why you have a teacher here. If you were taking notes about i's, and remember, you should already know this, there are 4 things for i's that you should probably memorize. And you should probably memorize for the ACT. In fact, I'm not going to say probably. You should memorize. They will be on the ACT. I, by itself, is the square root of negative 1. Okay? I squared is negative 1. Okay? I to the third is negative square root of negative 1. Okay? And then I to the fourth is just 1. Okay? And then I to the fifth repeats the process. So negative 1, I to the sixth is negative 1. So it repeats the process. Okay? So I to the 400, right? You can do by doing every 4 it's going to repeat. Every 4 it's going to repeat. So I to the 400 as a divisible of 4 is just simply, right? It's just going to be simply I to the 4th. So it's just 1. So that's pretty cool. So that's just something that you should know. So I squared is negative 1. So negative 2 times negative 1 is a ding ding. That's a positive 2. You can add that to the 12 and we get 14. Whenever you FOIL 2 complex numbers, no matter what those numbers are, you should get another single complex number like that. Okay? Okay, let's talk about complex conjugate. Conjugate is a word you should become familiar with. We're going to talk about it all the time in calculus. A conjugate is literally the same thing as the answer you were given. So here's a plus bi. Conjugate is the same thing. The only thing different is the middle symbol. So the conjugate of a plus bi is a minus bi. So the complex conjugate of a plus bi is a minus bi. So the conjugate of 5 plus 3 would be 5 minus 3. Okay. What happens when you have when you multiply conjugates together? And you should memorize this and write this down, and I hope you are. When you multiply conjugates together, you get a difference of 2 squares. When you multiply conjugates together, you're going to get a difference of 2 squares. Say it one more time. That when you multiply conjugates together, you're going to get difference of two squares. Let me say it one more time. When you multiply conjugates together, you're going to get difference of two squares, meaning that to get rid of the and I'm going to do an example for you. I don't like this example. You're going to get, when you multiply this by its conjugate, you're going to get a squared minus bi squared. I don't like how they've written it, but I'll show you. So here's some examples if you want to work through. But I want to show you some examples when we do the practice problem. Now I'm going to see here, because I want to see what I have on here as the practice problem. There's complex. So, okay, let's talk about discriminant now. Discriminants are very important, and if you are writing notes or you're starring notes or you're saying where you're going to find answers for on your homework, I would go ahead and screenshot this. I would go ahead and copy this down. I would go ahead and write this. I would go ahead and memorize this. But basically, here's the idea. When you have a quadratic equation, so the x squared plus bx plus c, what we did before, when you have a quadratic equation, you're either going to get two real answers, right? And so you're going to get two real answers when your graph looks like this. Let me bring up this. Let me make this new. So when your graph looks like this, this is how you're going to get two answers. Because remember, a quadratic equation is either going to look like, this or this, right? This is going to give you two answers because it crosses the x-axis in two spots, right? Bloop, bloop. That's going to give you two answers. Now, you might get a quadratic equation that only has one answer. And that's going to look like this. Okay, or you might get a quadratic that's going to give you no real answers. And that's going to look like this, right? Because it's not going to touch through the x-axis. This is when you're going to get two complex answers as your answer to the equation, right? Because that's really what an answer to a quadratic is. So how can we tell that? Well, we're going to think of the quadratic formula, right? Quadratic formula was opposite of b plus or minus square root of b squared minus 4 times a times c all over 2a. What's going to determine if it's imaginary, if it's one number, if it's two numbers, is this guy under the square root. If we get an answer and it's negative under here, we're going to get a complex answer. If we're going to get an answer under here and it's going to be 0, it doesn't matter what it's going to be one answer no matter what. And if we get a positive answer under here, we're going to get two real answers. So that's what the discriminant is. The discriminant is just the undercarriage of the square root in the quadratic formula. And here's the notes. If the discriminant is positive, there are two real solutions. If it's 0, there is one real solution. If it's negative, there are imaginary answers that are complex solutions. So here's a quadratic equation. If you would do a discriminant, you would get negative answer, which means it's going to be two complex solutions. So there's your solutions to that right there. Okay, so there's the quick review. Go ahead and try to do those on your own and see if you understand it. But we're going to go ahead and look at the review here for your homework. Okay. So what we're going to do is we're going to add complex numbers. We're going to multiply complex numbers like we were foiling. We're going to rationalize the bottom of the denominator, and then we're going to use the discriminant in 3 different ways. And I'll show you each way here, okay? So the first thing we're going to do is this number 1 here, which is negative 1 plus I. So we're going to get negative 1 plus I. We're going to add that to 2 minus 7i. All you have to do is, if you're adding it, you can go ahead and just get rid of all your parentheses. If you're subtracting it, before you get rid of your parentheses, make sure you distribute that negative. I guarantee you on some of your homework you're not going to do that. Please make sure you distribute your negative. So because I'm adding, I'm going to go ahead and get rid of all my parentheses. And then I'm going to combine like terms. So I'm going to show you different colors here to show you what I'm talking about. I'm going to combine my i's, and then I'm going to combine my real numbers. Oh, didn't mean to do that like that. So when I combine my real numbers, I'm going to get negative 2 plus 1, which is 1. And then 1i minus 7 i's is minus 6i. And that's how you get B as your answer for that, which is what we got. Next thing I have here is I don't really have it foiling, but I'm having it distributed. So it's the same thing. So if you need help with foiling, ask me and I can do an example for you, especially on one of the homeworks, but you should know how to foil. So we're going to do 8i and then we're going to multiply that by negative 3i. And then we're going to multiply that by negative 8 minus 5i. And here's what you're going to do. You're going to distribute some. I'd like to do this. So when you do these, it's going to be 8 times negative 3. And 8 times negative 3 is negative 24. And then you're going to get I squared. Make sure you take these slow because a lot of times kids are like, oh, this is super easy. And then they miss certain small steps here and there, okay? Remember, we said I squared was the same thing as negative 1. So go ahead and change that to negative 1. And multiplied by negative 1. Right? Okay. So negative 24 times negative 1 is a ding-ding. It just becomes 24 times negative 8 minus 5i. And then you're going to multiply 24 times negative 8 and 24 times negative 5. And when you do that, you're going to get negative 192 minus 120i. Okay? Here's where I really want you to follow along with me doing this, okay? Especially if you are unsure of conjugates. This is probably going to be the hardest part of the homework. So really need you to pay attention to what I'm doing here, okay? Let's go ahead and make it new here. Okay. So it's going to be 6i all over negative 8 plus 8i. Okay, when you have complex numbers on the bottom, remember what you want to do is multiply by the conjugate. Multiply by the conjugate. I'm going to tell you right now in calculus we're going to multiply by conjugates a lot. Now if we were in a hour-and-a-half class, I would show you how multiplying by conjugates give you a difference of 2 squares. But we're not. I'm just going to show you that it's a difference of 2 squares, meaning this. It's a difference, okay, of these first two things squared, so it's negative 8 squared, and the next two things squared. Remember, this will get rid of the I, because that's what we're trying to get rid of. And then from here, you just multiply and distribute the top. So it's going to be 6 times negative 8, which is negative 48. I. 6i times 8i was just a pot of 48. I squared. Okay? Okay, so when we do the top, remember that becomes a negative 1, right? Okay, so negative 8 squared is 64. And then it's 64 times I squared, which is negative 1. And we're going to continue. right? You're going to get negative 48i minus 48 all over 128. And that's going to reduce, let's see here, we're on 3. That's going to reduce to this one right here. Negative 3i plus 3 all over, oh, hold on, I'm so sorry about this. Make sure you, I didn't make that a conjugate. It's ridiculous. I'm sorry about that. No wonder it didn't seem right at the top there. Minus, so this would be a, so easy to make one little mistake, and as you can see, I do it all the time, and I made a mistake here, so that would be this. And that would reduce to that one. Now let's say you didn't want to do all that, reducing, because that's going to be big numbers. Before you even got to all this, I'm going to do this problem for you again, but I'm going to reduce in the beginning to make it easier on myself. And if you can try to reduce in the beginning, do it. It makes it so much easier. So what I want you to do is I want you to look at this blue equation, because this was what was given to you on the homework or the practice problems, right? And I'm going to do another one for you. Probably at the end of this video I'll do another one for you on the homework to kind of work this through you. This can all be reduced by 2. So when you reduce that by 2, you're going to get 3i over negative 4 plus 4i. Right? And I'm actually going to reduce this more. I'm going to reduce it to this. Negative 1 plus I. When you do this, you want to multiply by the conjugate. Right? Now let's see if you can do the difference of 2 squares at the bottom. Before I write it down. So try to pause it and see if you can do it. Okay, I'm going to go ahead and do it. So it becomes a difference of 2 squares. So it's negative 1 squared, which is 1, minus I squared. And then the next thing I would do is I would go ahead and change all your I squareds to negative 1s. So it becomes negative 3I plus 3 over 4 times 1 plus 1, which equals 2. So it would be negative 3i plus 3 over 8, which is the answer there. So if you're following along, I'm going to do one of your homeworks for you so we make sure we're all on the same page here. So the next thing I want to do is I want you to find the discriminant. And remember, the discriminant is just what's under the square root of the quadratic formula. So it's going to be b squared minus 4 times a times c. And remember, a is in front of n squared, b is in front of just n, and c is this one. So a is negative 7, negative 5, 8, negative 7, negative 5, and then 8. Can't reduce any of those, so I'm just going to plug in here. So it's going to be negative 5 squared minus 4 times negative 7 times 8. So it's going to be 25 plus, because that's a ding ding, 4 times 7 times 8. 4 times 7 times 8 is 224. Had to use the calculator on that one. And that's going to be 249 is your answer for that one. So D. Okay, let's now go ahead and do the next one. So let's get our eraser out here. We're going to erase some of this. I feel like this is T. And when you do these, you should get, you should decide if it's going to be 1, none, or 2 real, 1 real, or 2 imaginary. So we're going to look here. So we got -5, 5, and 10. -5, 5, and 10. And all that reduces by 5. So when you do that, I'm going to do this in a different color. So that's going to be -1, 1, 2, because it all reduces. So it's going to be 1 squared minus 4 times -1 times 2. And you would get the same answer if you didn't reduce. So don't worry about that if you didn't see it. So that's a ding ding. So it's going to be 1 plus 4 times 1 times 2 is 8. So it's going to be 9. So since it's positive, it's 2 real numbers, right? So that's why 5 is A. If it's 0, if your answer is 0, it's going to be 1. And if your answer is negative, your answers are going to be an imaginary number. They're going to be complex, so you'd select none, okay? And then lastly is I'm going to put those two together for you. Right, so we need to figure out A, B, and C. Okay, so let's see what they are here. 4, 1, and -3. So it's going to be, I'm going to make those equal signs so they don't think they're negatives. So it's going to be B squared minus 4 times A times C. We have a ding ding here. So it's going to be 1 plus 12 times 3, which is 36. So it's going to be 37 positive. Oh wow, I did that wrong. Where did I go wrong here? Oh, can't do math right, can I? So, let me do math right. 4 times 3 is 12. 12 times 4 is 48. So it won't be 37. It's going to be 49 positive. And when you get 49 positive, it's going to be 2 reals or 2 imaginary. Well, since it's positive, it's 2 reals. So it'd be 6. So go ahead and, if you feel confident with this, go ahead and do your homework and go ahead and put it in the Google form. If not, I'm going to try to do one more where I'm rationalizing this for you. Remember, with these, you got to distribute that negative, so it's going to be 6 plus 6i plus 7 plus 5i. Make sure you distribute those negatives. So I got some foiling in there for you. Okay, let's go ahead and rationalize. I will go ahead and rationalize this number 9 here. So it's going to be 10i, 10i, negative 4 minus 5i. Remember, when you want to rationalize these, you want to multiply by the conjugate. The conjugate is the same thing as the bottom. The only thing that's different is the symbol on the inside. So it's negative 4 plus 5i. We want to do the same up there. Okay. So you kind of, when you're dealing with these, you kind of are dealing with top and bottom. They're two different operations. So the bottom is going to be the difference of 2 squares. So it's going to be negative 4 squared, and it's the difference of the 2 squares. So 5i squared. And then you got 10i times this, so it's going to be negative 40i. And then it's going to be plus 50i squared. Okay, so I would go ahead and try to reduce as much as you can. Remember that I squared is a negative 1, so this becomes negative 40i minus 50. Negative 4 squared is 16. Minus, remember 5 squared is 25. And I squared is negative 1. So that becomes a ding ding down there. So we got negative 40i minus 50 over 16 plus 25. So you get negative 40i minus 50 over 41. I'm going to hope that's an answer on there. Yep. So the answer we got was negative 40i minus 50. So it would be D. Just make sure you're doing those and making sure you're watching your negatives. Let me make sure I did that right. Yes. So again, if you have any need for help, please feel free to ask me. I'm always here. Good luck, but I know you'll do well.